In lesson 4.2, we're going to deal with this main concept that we have talked about throughout the course, this idea of risk and return, which I've mentioned before is one of the main concepts in investing. It's a very important relationship. And in this lesson, what we will look at is not only the relationship between risk and return, but also how do we calculate what the risk is of an investment, and how do we use this information when we're dealing with client portfolios. So when we're dealing with an investment, we have to first calculate what the return or the expected return on that investment is, and then there are a couple of different ways that we can determine what the risk of the investment is. No matter which type of scenario we look at, what we are looking at is statistical measurement to determine what the risk level is. So we look at something called the variance, and from the variance we can determine what our ultimate goal is, the standard deviation. So when we calculate the expected return, we are calculating the mean return for our investment. And when we're calculating risk, we're calculating standard deviation. There are a couple of different scenarios that we can deal with when we're making these calculations, and we will go through in this particular lesson examples of each of those types of scenarios. The first type of scenario is one where you have an analyst who has gone through the economic situation that's currently in place and has looked at scenarios for the future and has said, based on their analysis, here's what I think is going to happen in the future, in the next year for the economy. Here are the probabilities of these things occurring, and here's what I think will happen to the stock in each of these scenarios. So basically what they've said is, I think maybe there are 3 possible scenarios that could happen in the next year. We could have a boom economy, we could have a normal economy, or we could have a recession. And I think that it's about a 60% chance we'll have a boom economy, a 20% chance it'll be normal, and a 20% chance of a recession. And in the event of a boom economy, here's what I think will happen to the stock's price. In a normal economy, here's what I think will happen. And in a recession, here's what I think will happen. So what we do in this case is we take all of that information and we determine, based on these probabilities, what is the expected return for this investment. Once we have that expected return, we can then use it plus the information we have on the probabilities and the possible scenarios, and we can determine what the variance and the standard deviation are as well, based on what the analyst has forecast. So that's one method of going about it. The other method is to look at the past rather than the future. So in this case, we look at a stock, and we look at the last 10 or 15 years of returns, and we determine, based on the past returns, what do we think the expected return is for this investment, and based on the way the stock has moved in the past, what do we think the risk level of the investment is? Because risk is really trying to quantify that variance or that variation from the expected return. How much has the return on this investment deviated from that expected return? This slide is just in place to make sure that I've indicated to you that when we talk about expected return, we can refer to it as either the expected return or the mean return. The way that we tend to refer to the return on the investments is that of expected return. So as I've mentioned before, we start with the calculation of the risk of an investment with the variance. So what the variance is measuring is how much does the investment's return over periods of time or during possible outcomes differ from what the expected or the mean or average return is. Okay, so in this slide I've just said that what we're measuring here is the uncertainty, because that's what risk is. It's how uncertain am I about how close I'll get to that average return. So in the case of future prospects, if you're given 3 possible outcomes, we're looking at how much does each possibility vary from that expected return or average return. If we're looking at historical outcomes, we're looking at each year. How much did it vary from the average return over that period of time? So the definition of variance is that it is the average of the sum of the squared deviations. And as we go through the examples on how to calculate variance, you'll see how that is calculated. But in words, that's what the definition of variance is. Once we have the variance, all we have to do to determine the standard deviation is take the square root of it. You'll see when we do the calculations that when we're calculating variance, we're squaring things, and what we're squaring are percentages. So the final answer that we get is in percent squared, which really doesn't mean much to us because our average return is in a percentage form. So that's the reason that we take the square root to determine the standard deviation, because it puts the two things in the same dimension, both in percent rather than 1 in percent and 1 in percent squared. So here's an example using the first type of scenario that we can have to determine our risk and return on an investment. So we've got an investment where we've been given 3 possible outcomes for the future: a boom, a normal economy, and a weak economy. The boom has a 25% probability of occurring, the normal economy 50% probability, and the weak economy 25% probability. In the event that the economy booms, the analyst has said that this particular stock will have a return of 8.6%. In a normal economy, the stock is expected to return 5.7%, and in a weak economy, you will have a loss of 2.3% on this stock. So when we figure out what the expected return is, all we're doing is a weighted average of those probabilities. So we multiply the 25% probability of the boom with the rate of return associated with the boom. We multiply the 50% probability of the normal economy with the rate of return of the normal economy, and the same for the weak economy. Add them up, we get 4.43%. That's the weighted average of those 3 possibilities. That's our expected return for this particular stock. And as I said, once you have the expected return, then you can use that information along with the probabilities that you've been given to determine the variance. Because we've determined that our expected return is 4.43%. So all we have to figure out now is how much does each of these possible situations differ from 4.43%. And we said that the variance was the sum of the squared deviations, sum of the average of the squared deviations. So all we have to do then is take a look at the deviation, which in the case of the boom economy, the stock, if you'll recall, was expected to return 8.6%. This differs from 4.43%, so we figure out the difference there, square it, and multiply it by its probability. Then for the normal economy, do the same thing. The 5.7 return minus our expected return, square it, multiply it by its probability. And the same thing for the weak economy. Then we add them together, we get a variance of 27.01, and that would be in percent squared. So we take the square root of that to get a 5.2% standard deviation. So now, for this particular stock, we have determined it has an expected return of 4.43% and a standard deviation of 5.2%. Now, as I mentioned, there is another way of going about this. Rather than dealing with forecasts for the future, we can look at actual historical returns. So we may not have an analyst telling us what the probabilities of future outcomes are. So we can look at these past returns and make some inferences regarding those. Now, in the event that you're dealing with historical returns, the expected return is really very simple. It's just the arithmetic average, or what we are used to calculating as the average of the returns. So if we have 8 years worth of returns, we add all 8 years together and divide by 8. This gives us our expected return for the stock. The variance is still the average of the sum of the squared deviations. So in this case, we do something just a little different. we still square the deviations as we did in the last example. We still add them together as we did in the last example. But we don't have any probabilities to multiply them by to get the average. So we divide by, instead of n, or the number of periods that we're dealing with, for statistical correctness, we divide by n minus 1. So in the case that we had 8 years worth of returns, we would divide by 7. So in this particular example, we've got 5 years worth of returns for a stock from 1999 to 2003. And I've mentioned here on the slide that when you're calculating the expected return and you're using historical data, you're just doing the arithmetic average of the returns. So in this case, we would take all 5 returns, add them up and divide by 5 to get our expected return. From there, we can use the same information we have here along with that expected return to determine the variance in the standard deviation. So in the next couple of slides, we'll go through those calculations. So you'll notice here in the calculation of the return, we simply took the 5 years worth of returns, added them together, divided by 5, and this gave us an expected return of 9.69% for this particular investment. Now at first sight it may look as though this is a difficult type of calculation, but we're really doing the same thing that we did the last time. It's just set up in a table to make it a little more clear. So in 1999, we had a rate of return that was 5.31 different from our average return that we calculated on the previous slide. When we square that, we get 28.1961. We do the same thing for every year. So we take the rate of return that was received in that year minus our expected return that we just calculated. That gives us our deviation, and then we square it. We said that the variance is the sum of the squared deviations and then averaged, so we add them all together. So in this case, when you added all 5 of the squared deviations, you get 95.322, and then we said to divide by n minus 1 would give us our average. So we have a variance of 23.8305. That's in percent squared, so to get our standard deviation we just do the square root, and we have a standard deviation of 4.88%. The writing that follows these slides in this particular lesson will give you some more examples of how to do these calculations, and you'll be given some opportunity to do some questions and practice those calculations prior to having to do them on a test.